In our math problem, we have 48 times 35. We're going to go ahead and first use the area model, and then we're going to make a connection to how this is similar to standard algorithm. Many students have used the area model in 4th grade, so when we use the standard algorithm, it might be newer to some students. I know a couple students have seen it. So we're going to see how they look similar. So we have 48. We need to first decompose this number. So what I mean by when we decompose is you're going to look at that number and say how many tens, how many ones, and if there was a hundreds place value in this position, you would ask how many hundreds. But this is only 2 digits, so we only have tens and ones. So when I look at this number, I'm going to say how many tens do I have? Well, I know the 4 is in the tens column, and I have 40. And then I'm going to look at the 8, and I see that the 8 is in the ones column. So I only have 8 ones. So you put those numbers right there on your chart, on your area model, and that's how you set up the first number. The second number is 35. So when I set up this number, I'm going to kind of set it up backwards. And when we connect it to standard algorithm, you'll kind of see why. When you solve in standard algorithm, you start with the ones place value, and then you work your way up to the tens, and then if there was a hundreds place value, you would do that. So I'm first going to put the 5 on my place value chart. So how many ones do I have total? I have 5 because the 5 is in the ones position. And then I'm going to look and I'm going to say how many tens do I have? And I see that I have 30. Okay, so this is how it looks so far. And then I'm going to underline my zeros just so I know that they're there in my tens positions. So then we can just multiply. I'm going to do 5 times 40 first. The first thing I want to do is go, is there a basic fact? Because 5 times 40 is a lot if I counted by my 5s to solve this. So I see that I know 5 times 4, and 5 times 4 is 20. But then there's another 0. Since there's another 0, I can just bring it down because I know 5 times 0 is 0. So I have 200 in that box. Then I'm going to go over to the 8 box. Well, I know that 5 times 8 is 40 because if I count by my 5s, it's 40. I don't have to add any zeros because none of the digits had it. Then if I go to the next place value, I'm at the 30. So now I just multiplied by my 1s. Now I'm going to be multiplying by my 10s. So if I look at that and I go 30 times 40, that's a pretty big number. Is there a basic fact that I know? And I see that I know 3 times 4. 3 times 4 is 12. So I'm going to put that in my box first. Then I'm going to look next. There's 2 zeros. So then I'm going to add my 2 zeros because I know 0 times 4 is 0 and 0 times 3 is 0. Next, I'm going to go to the next box. So then I have 3 times 8. And I know that 3 times 8 is 24. And if you are really struggling, you can use your multiplication chart to help you. And then I see that there's a 0, so 0 times 8 would be 0. So I have 240. Next step, you add them up. So you could add it up below. So if I take my first row, which is this one, I have 240 because 200 plus 40 is 240. So I'm going to write that right here. Then I look at the next box. I have 1,200 plus 240. Okay. 0 plus 0 is 0. 4 plus 0 is 4. 2 plus 2 is 4. And then the 1. So it's 1,440. The next step, I'm going to add 0 plus 0 is 0. 4 plus 4 is 8. 4 plus 2 is 6. And then 1 plus, and I can add a 0 to help me remember, 1 plus 0 is 1. So my final answer is 1,680. Now we're going to do the standard algorithm and just see how this connects with it.